Hello, class.
There you go. There's your hello from whatever his name is. All right. All right, warm up. Okay. So the first zone is which one? Limnetic. You can think, I mean, the only thing I can come up with is you go out on a limb to get to the middle of a lake. I don't know. Okay. So we have limnetic. Number 2, profundal zone. It's deep. Okay. Number 3, benthic. This is the mucky bottom where lots of organisms live. Okay. And then we have littoral. Somebody said the litter is by the shore. Whatever helps you. Okay. Which zone would we find cattails and grasses? Littoral, right? In which zone would we find crabs and crayfish? Probably in the benthic zone. Benthic zone on the bottom. Where would we not find algae? Remember, algae needs sunlight, so where would we not find sunlight? 2, right? Profundal zone and the benthic zone, right? So we did talk about like the euphotic zone. So the euphotic zone is just the top layer of that limnetic zone where there's the most sunlight. Okay. All right, I have flashcards. We are going to review. Okay. So what can you tell me? Which layer of the atmosphere is the closest to Earth? Troposphere. Okay. Which layer of the atmosphere has the ozone layer? Stratosphere. Which layer of the atmosphere has the weather? Troposphere, the one closest to the Earth. What's the warmest layer? Thermosphere. All right. How does pressure change with altitude? As we go up higher, what happens to pressure? Decreases. Okay, pressure decreases. There's less air pushing on it. How does density change with altitude? So density is the number of air particles. As we go up, it decreases. Okay. How does temperature change with latitude? In the troposphere, what happens as we go higher? Decreases. But what's the shape of this temperature graph? The M, right? So it depends on which layer you're in because it does different things. Okay. What's the difference between weather and climate? Okay, long term, like how long term? Like 10 years. So climate is like the weather over a period of like 10 years. Okay. What are the top 2 factors determining climate? Precipitation and temperature. What's albedo? Okay, yep, the amount of reflection we get off of a surface, right? So we talked about the poles having high albedo. What happens to air as it rises? What happens to the temperature? It gets cold and it expands because there's less pressure pushing on it. Okay. Where do we find Hadley cells? In the middle. 0 and 30. So the equator and 30 degrees. What about Ferrel cells? 30 and 60. They're the next ones. What about polar cells? 60, 90. Okay. Rain shadow effect. Where do we get the rain on a mountain? The side where the wind is coming from, right? The windward side. The leeward side is going to be dry. What's the Coriolis effect? What does it make objects do? Makes objects curve, right? So objects can't go in a straight line, typically because the Earth is spinning. That's what we saw, you guys, when I drew on this ball, right? Okay. When the air comes down at 30, it's going to curve. This is what causes those trade winds. Remember, these are trade winds. Okay. Anyone remember what the top winds are called? Between 30 and 60. They're not the trade winds. They are westerlies. Okay. What causes the seasons? Okay, the tilt of the Earth, right? It's tilted at 23.5 degrees. And when the northern hemisphere is facing the sun, it is summer. What are gyres? What are these? Big currents, right? These are the whirlpools we talked about, where we can occasionally get trash, okay, floating inside of them. What's upwelling?
Cold water, cold nutrient-rich water
Comes up, right? And they like it because there's a lot of nutrients coming up there, right? And so we get a lot more productive ecosystems when we have upwelling. And then thermohaline circulation, salt and temperature, right? So we're redistributing salt and heat throughout the world, okay? And it's basically what happens is we're mixing the deep water and the surface water. So whereas gyres were on the surface, right, and they're just currents that are spinning, these are mixing deep water and surface level water. These are the currents that, you know, Marlin and Dory go on, right, and Finding Nemo, okay? And scientists are concerned that with climate change, it might stop, which would mean we would not be redistributing the heat, and the organisms that use those currents to travel would not be able to use them. All right, El Nino. What happens during El Nino? Okay, no more upwelling. What else, Charlotte?
The heat goes more toward the south.
Right, so towards South America. Good. So normally we get those trade winds and they're pushing that heat away from South America. But when those trade winds reverse, that heat flows back to South America. So what does the weather look like in South America then during El Nino? Hot and warm, okay? Hot, warm, rainy, all right? And so the fish don't like that because the nutrients don't come up. There's a lot of hot water. Because they don't have the nutrients for the phytoplankton, then the fishies end up dying, okay? All right, good. Here's what we're going to do today. We're going to talk about some aquatic ecosystems. Let's talk about freshwater ecosystems, okay? With freshwater, we talked about lakes. What other freshwater ecosystems do we have?
Rivers.
Ponds, rivers, good, okay? So we have lots of different things. What about marine ecosystems? We have the ocean. Anything else? The seas? Coral reefs. We're going to talk about mangroves. Okay, so today we have mangroves. I want to show you some pictures because you probably have never seen a mangrove. I went to a mangrove in Ecuador, so I have pictures of it. All right, so this is Isla Corazon. It is off the coast of Ecuador. Once upon a time, Ms. Frankson went and lived in Ecuador for a month in a treehouse on an organic farm in college. No, it was 19. All right, so we have mangroves. These are the mangroves that we went and visited. It basically looks like a big tangle of thickets. These are all their roots. Basically, they get these branches and these big roots that come down, and some of their branches end up becoming roots because they just like go in the soil and form roots. But it's like a big tangle. But then up at the top, you'll get all of these leaves, and it'll look like actually like a tree. Isla Corazon. So as you can see, here's like a crab, right? So they provide a lot of homes for different sea life, especially the kind of life that like can't live like out in the big open ocean waters, because as you can imagine, when water comes in here, these roots kind of break it, right? So it's going to be a little bit more gentle of a tide. This is me apparently glaring in the background. This is Emma. She is dropping a mangrove seed, right? So we planted some mangroves, so you just drop it down and then they grow. And then from the top, these are what all of the trees look like. We climbed up a tower, okay? So there you go, baby Ms. Frankson. All right, so mangroves on your desk. You have an article on mangroves, so take that out. Who needs one? If you need one, come grab one up front. So mangroves are one of the aquatic biomes we're going to be talking about. So follow along, I'm going to read through this. So Amazon mangrove forest stores twice as much carbon per acre as region's famous rainforest. Okay? Scientists have determined for the first time that Amazon's waterlogged coastal mangrove forests, which are being clear-cut for cattle pastures and shrimp ponds, store significantly more carbon per acre than the region's famous farmland. Okay? The long-term study recently published in the journal Biology Letters provides a better understanding of how mangrove deforestation contributes to the greenhouse gas effect, one of the leading causes of global warming, said J. Boone Kaufman, an ecologist at Oregon State University who led the research. The Brazilian mangrove forest fringes the entirety of the Atlantic coast at the mouth of the Amazon, the largest river in the world, with the largest mangrove forest. Although preservation of the Amazon rainforest has been the subject of intense awareness efforts over the last few decades, less attention has been paid to the Amazon mangroves. Mangroves represent 0.6% of all the world's tropical forests, but their deforestation accounts for as much as 12% of greenhouse gas emissions that come from all tropical deforestation. Over 25 years, we found 2 to 3 more times more carbon stored in the mangroves than in the rainforest, said Kaufman, a senior researcher professor at OSU's College of Agricultural Sciences. When those forests are cut down, they lose carbon, creating far more greenhouse gases than when the forests are cleared. Mangroves deserve conservation and participation in climate change mitigation actions throughout the world. Mangroves are a group of trees and shrubs that live in tropical coastal intertidal zones. Okay? There are about 80 different species of mangrove trees. All of these trees grow in areas of waterlogged soils where slow-moving waters allow fine sediments to accumulate. In these environments, mangroves sequester significant quantities of carbon that is stored for centuries. For the study, the researchers visited 9 mangroves and 3 salt marshes within the Brazilian Amazon. The Oregon coast, like much of the United States, features salt marshes along its coast and estuaries. Salt marshes, mangroves, and seagrass communities are collectively referred to as blue carbon because they hold vast carbon reservoirs, and their conservation is of value with respect to climate change mitigation. Mangrove forests are also important for biodiversity. They are known as kindergarten of the seas. This is where young fish spawn and reproduce and spend the early parts of their lives. Clear-cutting mangroves presents another threat. The people who live along the coast just behind these forests become more vulnerable to storms when they are cut down, Kaufman said. Mangroves are important for storm surge protection, he said. When we destroy the mangroves, we make populations much more vulnerable to damage and death during hurricanes. More often, these are some of the poorest people on the planet. All right, so mangroves, what do they provide? What do they give us? What are some ecosystem services? What did you say? Habitats, right? They give us habitats for animals. What else? Why are they important? They hold carbon, right? Which would be important for climate change. What else do they help people? Okay, fishing. What at the very bottom did they say? Protection, right? So those mangroves, if a storm comes, okay, if we have a whole bunch of these mangrove trees, it's not going to hit the coast as hard because those mangrove trees are there to kind of break it apart, right? So they provide a lot of protection, okay? So these are mangroves. They're one type of aquatic ecosystem that we're going to be talking about, all right? Can you do me a favor, pass these forward? Next thing we're going to be looking at are coral reefs. What do we know about coral reefs already? Anyone? What does anyone know? Anyone know anything about corals? Okay, they're pretty, they're colorful. They're living. What else? When they die, they get bleached. Okay, what else? A lot of organisms live in them. Okay, so we're going to be talking about corals and why they are important and how they're becoming bleached. So I'm going to hand you a sheet. What I need you to do is look at the yellow sheet on your desk. If you don't have one, I'll come give you some. Take about 4 or 5 minutes and answer those questions using that yellow sheet on your desk. Okay, that talks about coral reefs. If you need a yellow sheet, they are up at the front. All right, on your worksheet, so what is a coral reef? Who can tell me? What's a coral reef? Okay, it's an ecosystem. What's it made out of? What are coral reefs made of? Okay, calcium skeleton. So calcium carbonate. You guys remember when I talked about the carbon cycle and how organisms use dissolved carbon dioxide to create their shells? Okay, calcium carbonate. So these calcium skeletons are basically made by coral. Coral is made up of what? It's two organisms. What are they? We've got a coral parrot. What else comes with it? Anyone? Okay, we get algae. That's super important. So the algae and the coral live together. Okay, algae and coral. It's two organisms. It's not just coral. It's not just algae. It's both of them together. They have a symbiotic relationship. It's actually mutualistic. They both benefit. The algae does photosynthesis, so it gets food, and the coral provides a home in exchange for getting some of that food from the algae. Okay, so the algae is actually what makes it colorful. So the second question says, list and describe two ecosystem services. So ecosystem services. What? Okay, yeah, food sources for other animals and for humans. What else? Yeah. Okay, protection from the coast. Good. What else? Provide habitat. Okay, what are some economic services or economic advantages? So when we talk about economics, we're talking about jobs or money. So what services does it provide for that? Tourism, income from tourism. Okay, we could talk about like how it gives fishermen like places to fish. Also says building materials, right? We get building materials from coral reefs. And then coral bleaching. What happens when coral gets bleached? What happens to the algae? The algae dies, and it actually gets expelled from the coral. So it leaves the coral, okay? Yep, so the algae gets kicked out of the house, okay? Gets kicked out, and then the algae is what gives it color, and eventually the coral dies afterwards. And the reason it dies is because, well, the algae was making food for it. And so if the algae is not making food for the coral, then the corals are going to end up dying. I have a picture up here that you can see. This is an image, I'll put it right here, of a coral reef. So the healthy, you can see colorful, okay, this is where it got bleached, and then eventually it will be dead, right? And so after a while it'll turn completely basically dark because it's dead. There's a little easier to see. Okay, so we're going to be talking about coral bleaching today. Where does it occur? And basically, where is it most common and how has it changed throughout the years? So you'll notice I have big maps over there. You guys are each going to get a location, and you're going to be putting on that map your location and how much coral bleaching it has gotten. Okay,